Alright, grade 12s. Welcome back to videos. This time we're going to look at transformations of logarithmic functions. So, as we've seen before, we can use a values, b values, h and k values to affect vertical and horizontal expansions and compressions, and for h and k, horizontal translations and vertical translations. We're going to start by looking at what that looks like for a log function. And over on the left here, you'll see that we've got log base 2 of x minus 3 minus 1. So we're going to start by graphing just y equals log base 2 of x. We did this yesterday, so we know that when y is 0, 2 to the 0 gives us the x value. So 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. If I do 2 to the negative 1, I'll get x is a half, and if 2 is negative 2, I'll get x is a quarter. And that gives us our log function. And remember that there's a vertical asymptote at x equals 0. Alright, now, if we have that, which is the graph that we've got here in red, then we can shift that graph to the right and down. We're going to shift it right 3, because of this minus 3, and down 1. So this is my purple graph from before, and if I shift it to the right 3, this point goes over 1, 2, 3, and down 1. This one goes right 3 and down 1, right 3 and down 1, right 3 and down 1, right 1, 2, 3 and down 1, and etc. My vertical asymptote is shifted to the right 3, and there's my graph. My asymptote is at x is equal to 3. My domain is all the values of x that are greater than 3. My range is all real values of y. My y-intercept doesn't exist. It's not applicable. And my x-intercept, I can see here, is at 1, 2, 3, 4, 5. Happened to work out quite nicely. X-intercept was at 5. There we go. Now I can do the same thing here with negative log base 3 of 2x plus 6. A reminder that when we've got this 2x plus 6 in here, we have to factor out the 2. So we get y is equal to negative log base 3 of 2 bracket x plus 3. So we start by graphing what log base 3 of x would look like. Again, when y is 0, we get 1. When y is 1, 3 to the 1 is 3 this time, and 3 squared will give us 4, 5, 6, 7, 8, 9. 3 to the negative 1, if 3 to the negative 1 equals our x value, that's 1/3, and 1/9 is really too close to graph, so I won't bother. And I get this curve here. Again, with the vertical asymptote at x equals 0. Alright, now, if I've got that graph, now I can deal with the horizontal compressions and the reflections in the x-axis. So there's a compression, it's half as wide, and it's reflected. So a point like this, half as wide, I shouldn't say half as wide, it's half the distance that it was from the y-axis. So this point here at 1 comes to a half, and then gets flipped over the x-axis, which doesn't really do anything. This point comes in half as far, so to 1.5, and then gets flipped over. This point, which is at 9, comes into 4.5, and then gets flipped over. And this one that was at 1/3 comes in at 6, which is really close, and gets flipped over. So we've done the horizontal compression, and we've done the reflection. go. And then the other thing we need to do is to take that purple piece and apply a translation to it. Remember, our function said x plus 3, which means left 3. Sorry about all the back and forth here, but doing this quick. So back 1, 2, 3, back 1, 2, 3, back 1, 2, 3, and back 1, 2, 3, etc. We're going to have our vertical asymptote here at x equals negative 3, and our graph comes in like so. Okay, so there's our function. Now doing it step by step like that can be a little tedious, so I want to show you a faster way to get there. I've been practicing a little bit just to see if it does in fact work nicely for you, and I really think it will. Okay, so here's a big long one. Y equals 2 log base 2 of 1/2. There should be a set of square brackets here. We can get rid of that, like this. Let me erase that, clean that up for you, give you time to copy that down. So we've got 2 log base 2 of 1/2 times x minus 4 minus 1. So here's what I think is a faster method for us to graph this. If we set the asymptote in the vertical translation guideline, so by the asymptote, I know that I'm moving it to the right 4, so I've done this here, and I'm going to be moving my graph down 1. So that's what I mean by my guideline, my translation, my vertical translation guideline. I've drawn it out here, not an asymptote. Okay, this is not an asymptote. It's simply a tool to help me out. Okay, it's like a new set of x and y axes, for example. Now, once I've got that, that's dealt with the 4 and the 1. I don't have to worry about that anymore. Then I place a few key points for log base 2 of x. And that's what I've done here. You know, if I think of y being 0 from this new set, I should have a point here at 1. If y is 1, x is 2. If y is 3, x is 4. And that's in green there underneath. Okay? And then if x is 3, or if y is 3, x is 8. 2 to the 3 being 1, 2, 3, 4, 5, 6, 7, 8 from my new asymptote. Same with these points down here. Now, from there, all I need to do is apply any stretches and reflections or compressions, etc. So this tells me it's going to be vertically expanded by 2, and it's going to be horizontally expanded by 2. So let's do the horizontal expansion and then the vertical expansion for each point. I'll start here. So a horizontal expansion brings me out to here, and a vertical expansion does nothing. Okay, it doesn't vertically expand off of that point, so it just stays right there. This point is already out 2, so it's going to go out 4, and then it's up 1 off the axis, so I'm going to go up twice as high. This point that was right here is at a height of 2 and out 4 to the right of the asymptote, so it's going to go up twice as far, 5, 6, 7, 8, and up twice as far to here. And this one is just off my graph, but it's going to be up there somewhere. This point is out twice as far and down twice as far. And this one is out twice as far and down twice as far. And then you can see that I just graph out. Okay. Let's try that again. Log base 2 log base 3 of negative x plus 1. Now in this one, if I factor out the negative, I get 2 log base 3 of negative 1 times x minus 1. Okay, so first, I set my asymptote in vertical translation guide. Well, my asymptote is just moving to the right one. I don't have a vertical translation, so I've drawn, an imaginary dotted line here, but really it's just my x-axis. So I've done this. Then I place a few key points for log base 3 of x, which I've done here. When y is 0, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared would be 9, 3 to the negative 1 is a third, and 3 to the negative 2 is a ninth, and that's too close. So I've got these key points right here. Then I just apply the stretches and the reflections. There's going to be a reflection in the y-axis and a vertical expansion by 2. So this one gets reflected in the y-axis to here, and then since there's a vertical expansion by 2, nothing happens because it's on the x-axis. This one gets reflected to back 1, 2, 3. It's at a height of 1, so its height gets doubled to 2. And if you imagine over here, there would have been a 9. So that gets reflected over 1, 2, 3, 4, 5, 6, 7, 8, 9 at a height of 2, which doubles to 4. This point here gets reflected over, down 1, so it gets doubled to negative 2, and that's enough. Graph it. And one final one for you. Y equals negative log base 3 of x plus 3 plus 9. Now, before we build our axes, which I've built for you, think about this. Okay. It is up 9. So the graph is going to be way up high, so I'm going to build my axis down low. And it's going to be left 3. My asymptote is going to be over here on the left, so I'm going to have my vertical axis slightly to the right. It's also going to be coming down. So it's going to be coming down towards my x-axis. So first thing I do, I set the asymptotes, okay, and that vertical translation guideline. So my asymptote is back 3, and I've got this guideline here that I've moved up 9. Then I placed a few key points for log base 3 of x. That would be at 1, and at 3, and at 1/3. So this would be kind of what log base 3 of x looks like. Then, there are no stretches or translations, so I'm just going to reflect it over that point. This point comes up, this one stays the same, this one reflects down, and I'm done. This purple line is my function. Okay. It really is quite fast. So what I've done is you're going to receive a handout that looks like this, and you've got a whole bunch of functions there, and you're just going to work through these quickly. Okay? Try going it the fast way. You can pause this, copy it out and graph it yourself. Pause here again, graph it out. Don't forget to factor and graph it yourself. And pause, copy, and again, graph it yourself. Good luck.